This is where we left off on the video, and currently there's a little bit of an issue where the wheels don't always stop in the correct order, 1, 2, and 3. And the reason is that when you click this button, it runs all three of the codes in all three of these spinner containers at the same time, and it runs them within one frame because they're not that complicated. Okay? So when within one frame, spinner 2 is trying to pull the, no, maybe it's in this code, the chop exec, yeah. Spinner 2 is trying to pull the time that we called stage 1 here from this operator path, right? We had to use this was in the video last week, so we use an absolute path to point to the length parameter in timer 1 in the spinner 1 object, and we're calling that stage 1 time, right? And then in spinner 3 we have a similar variable called stage 2, and it points to spinner 2 timer 1 par length, right? And so when we're adding stage 1 or stage 2 to that, it's pulling that value, but that value hasn't been updated yet for the time that you just pushed the button. So it's actually pulling the value from the last time you pushed the button, which is what is throwing off, which sometimes it works fine if it happened to be that the length was such that the wheels would stop the last time you pushed it, the wheels would stop in the correct order this time you push it, but obviously that's not going to happen every single time. So what we need to do is simply create a delay of only a 1 frame delay, which you won't really notice, before spinner 2 executes, and before an additional frame delay before spinner 3 executes. That way each one can get their variable populated with the current timer par length. Right? So it's a really simple fix. So here on going in from the button into spinner 2, we're going to insert an operator, and it's going to be a delay chop. Okay? And by default, it wants to have a 1 second delay, which is way longer than we need. So we want to change this to a frame. So go over here to this drop-down list and change that to frames. Then you'll notice that, well, you might not notice, and I didn't the first time, that it updates that to how many frames are in a second, and it runs this all the way up to 60. So we need to take this back down to 1 frame. That's all we need, is a single frame delay. Okay? Then, what do you think I would put here? Going into spinner 3. Same thing, right? Delay. And change this from 1 second to frames, and from 60 frames to 1 frame. Okay? Why would this not work necessarily? Anyone? Because spinner 2 and spinner 3 will still happen at the same time. How could I change that? I could do delay 2 frames, or maybe a little more elegantly, is I could take this button and instead drive it from the output of the previous delay. Then I know that that will always happen after this one, right? There is a conceivable notion that something glitched on your computer causing it to slow down, and delay 1 here hadn't quite executed by 2 milliseconds, and then delay 2 executes. And that conceivably could mess things up. And if you do it this way, this cannot execute until delay 1 executes, right? So that's a little bit more elegant. But you're right, yeah, that would probably work. All right, so that should fix the stoppage, wheel order stoppage. So let's try that out. I'm going to hit my little open, and we have random speeds, and they should stop 1, 2, and 3. 1, 2, and 3. And it will work every time that way. One, 2, and 3. Right? Okay, great. Next on the list. Some of you may have noticed that your wheels probably are spinning when you first turn on the patch, and they don't stop until you hit the button and it runs through one cycle, which obviously would be very confusing to a user. If they came up to the machine and the wheels were already spinning and just not stopping, they probably wouldn't even play. They'd say, this machine is broken, I'm not even going to bother. So I figured out what was wrong there. It was a really simple thing. So here in each spinner, we have this override here. And the way we had it before, the way you guys have it, is with random seed on top of math, like this. See on my, over here on the override parameters. And we want to actually put the math 2 to be before the random seed. That way, if there's no random seed change, it will go off of the top input first, which should be 0, so making it not spin. As soon as you change that, that will break this LFO down here. And the only thing there, the only reason why is you look at what the channel name is, and it's going to name the channel name of the output of the override based on its first input's channel name. And because we're isolating the done channel here on the select way back here in the chain, that channel, this channel chain is called done. So down here on this LFO, you guys probably had channel 1 here, chan 1, right, like that. Whoops, but actually like that. There we go.
I had 0.
Chan 0?
No, I just had lag and then 0.
Oh, well then yours would have worked anyway. Yeah, you guys all had 0 there? I couldn't remember whether I named the channel or not. Okay, so if you had 0, that will work. That's because that's just saying take the first channel. Take the first channel, I don't care what it's called. So that works. If yours are broken like mine, it's because that changed to the word done. So yeah, you could either put a 0 there or you could put a done there. I haven't decided what my favorite way of coding is as far as should I just use channel enumerators, the first channel, the second channel, starting from 0, so 0, 1, 2, 3, 4, or actually the name of the channel. I have a feeling, I've been using, I think the last couple classes I've been using enumerators because to avoid issues like this, but I have a feeling that I'm going to want to start using channel names because we're going to probably start working with tons and tons of channels, and it might get confusing when you're talking about channel 22 versus channel 23 of 45 channels, right? Especially if you're like dealing with like an Arduino interface that might have a whole bunch of data coming in, or a Connect sensor that has all your different like tracking points. Those tracking points, it's going to be really hard to remember that left elbow is channel 31 when the name of that channel is left elbow, right? That's a lot easier for me to work with. So this week I kind of started using the names. So it's up to you. For now, you can just leave it 0 if that's working fine. If not, you can change it to done because that's the name of the channel. Okay, so if you do that, if you just make sure that the coming out of the math 2 is the top input on this override, then it won't be spinning when you start that. And so make that change in spinner 2 and in spinner 3. I'll give you a minute. I got to pull out my notes anyway. And then just make sure your patch is still working. And if it isn't, let me know and I'll help you. We all made that change? Yes? Making it. All right, great. Take your time. I'm still pulling up my notes.
What's the decision that override makes? Just looks for one of them to change?
Yeah, is whatever changes gets precedence. So if both of them are changing, it basically is which one comes in first or comes in second on that frame.
Okay.
So yeah, if both could possibly change in the same frame, it's kind of a crapshoot. So you want to avoid that. But in our case, they're not, because that random seed only happens when you hit the button. That's when that value changes. Docs. Do I have a docs app? I can't remember. Yes, I do. Okay, there it is. All right. Did we finish those changes? No? Okay, great. I'm going off of Kathleen. You're going to have to, because she's the only one who's speaking up. All right, cool. So we made those changes. So now the wheels don't spin when you start, and they stop in the correct order. And you all got the code to work that made them stop right at the integer, correct? Mm-hmm. Great. So you should end up with something that's like a number 0.01 or 0.5 or 0.9, hopefully something below 0.1. Although for some reason mine sometimes is at 0.1. I haven't figured that out, but really 0.1 is close enough that you can't really tell. And it doesn't matter as soon as we add this next step. And the next step is we need to scrape off those floating point values and just use the integer values. And to do that, we can use our most versatile of channel operators, the math chop. So let's insert an object coming out of wheel post 1 and add a math. Okay, and as you can see, I call it the most versatile because it has all these different functions. Like here on op, there's all these different functions. It's got the multi-add, it's got the range. I don't know too much about the common. I guess you can change what channels you're looking at in the scope here on the common. But we're just going to, here under integer, change that from off. And it's either going to be ceiling or floor. So let's try ceiling. That rounds up. We want to round down, so let's change that to floor. And now it's scraped that off, the 0.088 in my case, whatever yours is, and it says 3, and that's exactly what we want. Now, what do you think we could do to do this on the other wheels? Anyone? It's really simple. What? Copy and paste, right? Yeah. We could have three math objects, but we don't need to, because the math, you can see, I don't know if I've mentioned this before, but you get clues about inputs in objects based on like not only the color of the input, but also its width. See how this wheel post 1, which is a null object here, just has a skinny green input? That means it only takes one channel in. This one, math 1, has a fat green input. Means it can take as many inputs as you want. So go ahead and just patch the other inputs in there. And wow, look at that. It just adds channels to that math object. Okay? So make sure that they're in this order coming in there so that we don't get our wheels mixed up. Right? We want wheel 1 to be channel 1, wheel 2 to be channel 2, and wheel 3 to be channel 3. And now we have this nice visual object that's showing us what our current numbers are on all 3 channels. We don't even really need to look at the slot machine for the purposes of programming. I can see exactly what those numbers are going to be. all in one object. 4, 2, 4, 8. Okay. So we fix that, we fix that. All right, so now it's time to do some logic. All right, so we're going to be taking these values and running them through a, guess what object do you think I would use? It's the same kind of objects we've been using before to analyze whether something is a particular number or not. The chop exec, right? The chop execute, which is actually a DAT, right? DAT chop execute, right? And we could go ahead and attach it to math 1 here, but then we'd be clicking the button 1,000 times before we got the numbers that we're looking for, because we want to be able to test these conditions and we don't want to have to wait for random chance to make us win. We're going to force wins. So we're going to actually attach it to a constant with 3 channels, and we'll just use that constant to test these conditions. So let's create that constant. So make a constant chop and call this constant chop. Let's name it. Call it logic test. Logic test. And do you know how you can get more than one channel into a constant? Anyone? We've done it once, I believe. Just type the name in. Good man. All right. Yeah, so down here, over looking at your parameters window, you have chan1 here. All you have to do is type in a name for the second channel, and it'll give you a second channel. Chan2, Chan3. I'm going to use the same labels that I have down here in the math, because then it'll make moving from one to the other really easy. And so now I won't be able to use the sliders because the sliders only go between 0 and 1, but I can type numbers in here and set these to whatever I want. So if I wanted them to be a jackpot, all lucky 7s, I can type in 3 7s, right? All right, so we're going to attach this to that, and to do that, you either have to, if you're adding a chop exec, you can actually right-click the output of the chop and then switch to DAT and then choose a chop execute, and it'll automatically create that association. Whoops. Or since we already made one, here on the chop execute, I can just specify logic test as the chop that I want to be looking at. Okay, and we're going to be, what are we going to do? We are going to be doing on to off. Oh, you know what? We actually don't want to have these two associated with each other, because we're actually going to, this chop exec is actually going to be reading the channels from this, but it has to have a point at which it reads it, right? We don't want it to be constantly analyzing the channels coming from the wheels, because then, like, if they happen to be still rolling and they rolled past 777, it says, hey, you won, even though the game's not even over yet. We have to wait for the game to be over and then read the wheels. So we need another object to say, game over, now look at logic test or look at math 1 and tell me if those values are the same. So for now, let's just use a button, because it can make a 0 or a 1. So comp button. And the problem with a button is that you can't associate this button with a chop exec, because it's actually a container with a bunch of objects in it. So it's just easiest to just attach a null to it and then reference the null. So I'm attaching a null to this button, and now if I make the viewer active, I can click on the button and the null turns to a 1. I can click off the button and the null turns to a 0. Instead of having to click that twice, let's just change the mode of the button to be momentary instead of toggle down. So here on button, on the parameters, and the button type, I'm changing that from toggle down to momentary. Now when I click the button, you get a 1. When I let go, I get a 0. So we're going to now change this chop exec to, instead of be looking at logic test, I made an error there. We actually want it to be looking at null 1. Okay? So it will execute when this null 1 changes to a 1. But it won't unless I...
Or null 4 or whatever.
Or whatever your current null object will be. Mine is null 1 because I don't have any more nulls out here.
Your nulls wheel pause.
Oh, because I named my nulls wheel posts.
Oh, let me see who's responsible.
All right. So yeah, whatever this is, point to it here in your chop executes chop parameter. Okay? All right, so now what do we want to do? We're going to, when we go from off to on, we need to look at logic test and what? Decide what's the condition we want to look at. What do we want to, what's the main thing you want to know in a slot machine? What's a win condition in a slot machine? All the numbers are just saying, thank you, Gabe. Okay, great. So we can just say, are all the numbers the same? First thing we have to do that is make sure that we're actually running the code for on to off. So here on chop execute, by default, it's set to value change. We're not interested in value change. We're interested in on to off, or off to on. So change that, turn that on so that it runs that code. Otherwise, it won't do anything. And now we need to actually write our code here. So if you did the Matthew Reagan tutorial, you'll know a little bit about if statements. And the way they work is Python is, first of all, Python is white space, they call it white space dependent. So it knows whether you're inside of an if statement or outside of that if statement based on whether you've tabbed over from your current position. So this, and you can see this return already is tabbed over, and that means it's part of this definition, def on to off, or def on off to on. It's a little confusing because it's like def on, but then it's off to on. So on off to on, do this. On while on, do that. On off, on to off, do that. We're going to do this first one, off to on. So we need to be tabbed over 1 for any code. Then we put an if. Then we put some conditionals, a colon. We go to the next line, and then we have to tab over again to put in more code there. But we have to define our ifs first. So what we're going to do is we're going to compare the channels here in logic test. So I can say if op open parentheses single quote logic, well, not logic, logic test end quote close parentheses and then open bracket, and I would want to say single quote chan 1 and now I've pointed to this chan 1. Then I can say so if I'm going to say they're all equal, I can say equals equals. Did he go over that one? Yeah, equals equals. So if you just put a single equals in pretty much any program, you're telling it that a variable, you're setting a variable value, but you're not comparing two things. Comparing two things, you have to use two equals signs. That's the logic operator. So equals equals, and now I would type out the same thing chan2, the same thing chan3, and that's a lot of typing. And I'd have to do that for every single condition that I'm defining. And it's a lot of typing, and it would get annoying. And so actually what we want to do is we're going to define our own little variable with a single equals sign, and we're going to point to this operator on that variable so that we don't have to type it 100 times, right? So above these defs, we're going to put our own little variables called wheel 1, 2, and 3. So up here, above the first def, you can put it below all these comments. You can say wheel 1 equals, and now go ahead and grab that code that we just made, this op logic test chan1. I'm going to cut mine, and I'm going to paste it here. Okay, so that's pointing to that. Now go ahead and copy this code, put it on the next line, and put it on the next line after that. And now just make some little changes. Wheel 1, wheel 2, and wheel 3. And then chan1, chan2, chan3. Now we can just say if wheel 1 equals wheel 2, and we won't have to type all that stuff. So back down here on our if statement. Are you guys all with me? Should I give you another minute?
You don't need semicolons, it's just the space.
No semicolons, it's just the space. See, that's the difference.
And the tabbing. Python.
Right. So tabbing is how they deal with the end of lines and stuff. And when they see a tab, they know that the previous line was finished. So if wheel 1 equals equals, what should I put now?
Wheel 2.
Wheel 2. And now what? Equals equals wheel 3. Now that is a little bit strange. That doesn't work that way in Max. It doesn't work that way in Arduino. You can't just say if variable 1 equals variable 2 equals variable 3. You would have to say if variable 1 equals variable 2 and variable 1 equals variable 3, or you could say variable 1 equals variable 2 and variable 2 equals variable 3. You don't have to do that in Python. They've given you that shortcut of just, you can just, if I had 10 variables, I could say equals 3, equals 4, equals 5, equals 6, up to 10. And it would let me keep going after that if I wanted to. So that's kind of cool, because I don't have to do a bunch of multi-conditionals or and statements. All right, so if wheel 1 equals wheel 2 equals wheel 3, then now we're on the next line, and we're tabbed over one space to be part of this if statement. Let's just print a conditional, or print something. Print, open parentheses, all the same. Okay. And let's just stop with that for a second. So now, go ahead and open your text tab. You might have a whole bunch of numbers here. Do you guys have all these numbers? I can't remember if I put it in the video or not. Oh, no? Okay, great, good. That was because in the code, when I did it, I guess I left it out of the video because I already knew it worked. I was debugging to try to figure out what was going on with those modulos, and I believe I have something that prints out that modulo, so I just need to comment that out. Let's see if I can find it really quick. There it is, print X. I'm going to comment that out. So you guys don't have this print X, right? You do? Okay, so in spinner 1, spinner 2, and in spinner 3, the chop exec that's attached to the LFO.
Yeah.
If you have a, you know, we have x equals op LFO1 chan1 modulo 1, and then I have print x. If you have a print x there, comment that out. So I'm going to comment that out. I'm going to come down to spinner 2, and I'm going to comment the same thing out on this. And in spinner 3, I'm going to comment out that. So that way it doesn't print out the moduluses. You guys all familiar with what's going on with modulus? Remainders, exactly. So yeah, it's like your old school. You remember when you first learned how to do division in grade school? And you're like, and they taught you to do, well, there's 5, or you're like 4, or 5 divided by 4, or no, 5 divided by 6 is, or 6, darn it, 6, 5 divided by 6. Yes, 5 divided by 6. You're like, there's 1 5 in the 6th, or there's 1 6.
No, there isn't.
1 5 in the 6th with a remainder of 1. So I'm sorry, 5 divided by 4 is there's 1 4 in there with a remainder of 1, right? So that's what the modulo does, is give you that remainder. So we're doing moduluses of 1, of integers, which gives you, which slices off the integer and just gives you the floating point values that will go back to 0 basically every time it's a full integer, which is how we made that thing stop on the full value. All right. Sorry, I'm confusing you, I'm sure. All right. Where are we? We are creating our logic test. Great. So I got rid of my print messages. Let me save this before I forget. And okay, so we have all the same thing. Okay, great. So now let's go ahead and test that. Make sure all of your logic, all your values in your logic test are all the same. And open up your text tab by hitting Alt-T. And then push the button. Make sure it's on view or active so you can actually push it. And it should print all the same. Yay? Yes?
Yes.
Great. Now change one of the values. And now push the button again. And nothing happens. Except for Shay, who breaks the internet. What happened?
Oh no, it works just fine.
Oh, okay, great.
I'm really bad at this game.
All right, so now nothing happens. But what we really want is to say, like, you lose or something, right? So we need to add another condition that's, if they're not all the same, to print out that you lose or something like that. So what do you think we should put? We have an if, else, great. So here on your chop exec, go to the next line. If it's indented in, go back, because this is a new statement, but it's still part of the def on, off to on. And we're going to say else. Now you're like, well, what about the logic operators for else? Well, we don't need any, because we're just saying if it's not the if, anything else, do this. So we don't need any operators after else. We just need a colon. And then we need to tab over, and we need to say print, print loser or something. You lose. Okay? So now let's try it again. Make sure your numbers are something that isn't all the same, and click the thing, and it says you lose. So that's working the way we want it to work. So go back and make them 3 different numbers and just make sure that that's still working. 2, 2, and 2. All the same. 2, 2, 1, lose. Great. That's what we want. All right, so now, what's the next thing that we might want to do in a slot machine? They always have something to draw the people in, like a really big prize, a jackpot prize. So I made the executive decision that the jackpot should be on the 7s, like a lucky 7, especially because I believe my slot machine is called Lucky Sevens slot machine. So how would I create a statement that tested if all 3 were 7s? There's more than one way to do this. Anybody want to venture a guess? No? The what? Yeah. So yeah, you could say, all right, so for now, let's just edit this one if statement instead of adding anything new. We'll just have the if and the else for now, and we'll just test for lucky 7s or nothing. All right, so if wheel 1 equaled 7, right? Okay, 7. And then what would I have to do? And what? Wheel 2 equals 7? Equals 7. And wheel 3 equals 7. That will probably work. It's not the way I did it, but I think it's totally valid. Let's try it out. So I'm still on 2, 2, 1. I get a lose. I'm going to change this to 7, 7, 7. And I should get a win. All the same. All the same, yeah. But let's change the text to jackpot. Anybody want to venture a guess of another way of doing it that uses less code, slightly less code? How about wheel 1 equals wheel 2 equals wheel 3 equals 7. See if that works. I'm going to change this to a different value, and it should get a lose condition. And now I'm going to change it to a 7, and I get a jackpot. So that works too, and has a little bit less code, a little bit more elegant, but just as valid. It's up to you. As long as you get these things to work, I don't care how many characters it takes to get it, but I'm going to try and show you the least amount of characters to get it done. All right. So what if now we want to have, right now all we're testing for is jackpot and lose. We're not testing for all the same. So how could we add another condition? If else. How do I type that? It's actually the other way around. Else if. And in a lot of different coding language you type else if. But in Python they want to be special, so they do elif. I wonder if it's like somebody's son's name was Elif or something. It sounds to me like it's an elf's name or something. Young Elif. All right. So, and the way that when we're doing else if, it's going to look at the first condition first. And if you satisfy that, it's going to done, and it won't look at anything else. Then it will look at the next elif. And then if that one doesn't, then it'll look at the next one. So when you build these win conditions, you want to start at your top prize and go down from there and end up with else you lose, right? So we're going to leave the wheel 1 equals wheel 2 equals wheel 3 equals 7 as jackpot, and now add an elif. Elif wheel 1 equals wheel 2 equals wheel 3 colon, don't forget your colon, then print all the same. Okay, so now we have 3 conditions. You have a jackpot, we have all the same, and we have lose. So let's test it out. If I am still on 777, I still get jackpot. Let's change this to 666. And I should get all the same. Whoops, I forgot to, my third channel didn't listen to me. Try that again. All the same, there we go. Is that working for everybody? No?
Yes.
Yes. Great. All right, so you can go on from here and just add more elifs. And let's do one more. Or no, let's do 2 more. If we're dealing with numbers, by the end of today, we will switch this over from numbers to the fruit symbols. But for right now, because it made it easier to see what we were doing, and because we could just generate it right in Touch Designer, all of our wheels have numbers on them. So if we're dealing with numbers instead of symbols, what might be an interesting, predictable condition other than all the same and other than all 7s? Yeah, there we go. 1, 2, 3. And what's another one like that? But different, but opposite. 3, 2, 1, right? So we'll call that an ascending and a descending condition. Does anybody want to venture a guess how we could make the computer do that? There is no logic operator that says that this one is 1 away from the one before. But there is math. Math exists that will do that. So what do you think I might do to determine if it's an ascending condition by using some simple math?
Plus 1, 2, whatever.
You're on the right track. Keep talking it out.
So it would be like if wheel 1 equals wheel 2. I don't know. If wheel 1 equals.
I'll give you a hint.
Yeah.
Bring them all in parity with wheel 2 using math.
Okay, so if wheel 1 equals wheel 2 minus 1.
Actually, try the. Okay, keep going. That could work.
And then wheel 3 would have to equal wheel 2 plus 1.
Yeah. So where would you put that math? Would you put it on wheel 2? You'd actually put it on wheel 1 and wheel 3. So what do we do if we have a 4, 5, 6? What do we do to 4 to make it into a 5?
You
Add 1.
Yeah.
What do we do on a 6 to make it into a 5? Minus 1. So you say wheel 1 plus 1 equals wheel 2 equals wheel 3 minus 1. We'll bring that wheel up and the other wheel down, and then you can just say, are they all, with that simple math, are they all the same? So let's try that. You had it. You totally had it. And I think if you had typed that out and you played with it for 15 to 20 minutes, you would have had it, or even less than that. I don't mean to say that it would take you that long. We're making win conditions. Yeah, exactly. So elif wheel 1 plus 1 equals wheel, whoops, I'm going to put a space in there, wheel 2 equals wheel 3 minus 1, colon, tab over, print We'll call this ascending. A-S-C-E-N-D-I-N-G, I think. Ascending condition. Okay, and then let's just copy that and paste it on the next line. Make sure you go back one tab, and now change this from wheel 1 plus 1 to wheel 1 minus 1, and wheel 3 minus 1 to wheel 3 plus 1, and this would be a descending condition. All right, let's try that out. So 666 is an all the same. 654 should be a descending condition. Descending condition, it works. Now let's try it. A 456. Ascending condition. Does that make sense what we did there? We're still just using the equals equals, but we're just using math to bring those two to the center wheel and then comparing them all. And this is, I think, what Scott was trying to allude to is that we're just doing this math for the comparison. We're not changing the values that are displayed on the wheels. We're not like, you're not going to see the 4 move to a 5 and the 6 move to a 5. That would be really confusing for the player. We're only doing that internally in the logic to be able to detect that change, right? Or to detect that condition of 4, 5, 6. So yeah, that's probably it, I think, for this simple logic. Let me see. I don't think I had anything else. Ascending, descending, matching, and jackpot, and lose. Yeah, that's all we need. Cool. If you want to, like, you can always put spaces between things, and Python doesn't care. As long as you don't accidentally put a weird character in there. And that can sometimes make it a little clearer for you about what's going on. All right, cool. So let's call this chop exec. Let's name this simple payout. All right, now let's hook this up to the. Let's hook this up. Right now we're still pointing to this logic test, and now what we want to do is hook it up to the actual output of these wheels instead of just our test object. So let's change our references on wheel 1, 2, and 3 here from logic test to math 1. Okay, and then it's still attached to this button. Ooh, what happened? It's mad at me. What's going on? It says the object none type is not subscriptable. Simple payout. Cannot find function and off. You're right. Thank you. Math 1. Math 1. There we go. Simple typo. Boom. So right now I have a 248, and it says you lose. It's still right now controlled by the button, right? So it's not going to actually work when we control the wheel until we manually hit this button. So how could we automatically hit this button or do something else rather than hitting a button to make it work? So right now, once the wheel stopped, I can hit the button and it's going to say you lose almost every single time because this is a really hard to win slot machine. When we add the complex payout, code, which is more extensive. There are a lot more win conditions, so it's a little bit easier to win. Still pretty hard. So we need to get rid of this button, and we need it to be automatic based on what's going on with the wheels. Let me see. 771. So close, but you lose. All right, so let's figure this out. So the first thing is we are simply creating a 1 or a 0. We can do that with more than just a button. We can do it with a constant also. Let's create a constant. And let's call this constant, let's give it a name, and let's call it spin complete. Spin complete. And attach that to the null. And then you can get rid of the button. Now if I wanted to manually control this, I could still manually control it by taking this slider and slamming it over to a 1. And it will then tell me I lose, just like it would normally. I can then slam it back to a 0 and then slam it back to a 1 again, and it'll every time I do that, it'll tell me I lose. Okay? So we don't want to do that. We want to have this automatically happen. So let's see. What do we do? What do we do? Yeah. So the first thing we want is when the spin happens, so we're going to say that spin complete 1 equals that the spin is actually complete, and that's when it does its thing. When the spin starts, we want this to go back to 0 so that we're saying the spin is not complete, right? So what do you think we could do to influence this based on what we're already doing? Anybody have a wild guess? I know this is a big ask, but I figured out I would ask. It's going to be inside the spinner containers. There's a bunch of different executions. There's 3 different executions that we do inside of these spin containers, and technically I could probably eliminate one of these and put them in the same, but it was just the way it built out because I was making it simple. And I didn't want to go back and conform things. I just left them as separate things. But there's a couple different things. We have this chop exec that happens when a button thing comes in. And that's what is making our random numbers for our timer and our random speed. We could put it there. We could also put it here under our timer callbacks, because both of these kind of operate right when you first hit that button. We probably wouldn't want to put it on chop exec 2 because we've disabled that at the beginning and we don't enable it until the end. This is what makes the thing roll up slowly till it gets to the integer and then stop. I'm going to put it under timer callbacks, because that's what I did in my notes. But you could probably just as easily put it under chop exec 1 here, and either one would work. So on the timer callbacks, this is kind of like a chop exec, but it's part of the timer chop. And it runs code based on the different conditions of the timer. So when the timer starts, we can do things. Right now, what we're doing is we're setting this chop exec 2 parameter value change to 0. I don't remember exactly why. Oh, that's where we're disabling that that thing so that it doesn't start running right when you first go. And then also we are adjusting that sustain parameter to 0.1 so that it creeps up when it gets to the end. So here we can add a third thing to do, and we can say op. Now we need to point to that spin complete. but it's not inside this container, so we can't use a relative reference. We have to either use an absolute reference or or we have to use code to point to something outside of this container. So I could say /project1 / spin complete, or an easier way is just say ... / spin complete, and make sure you spell it and capitalize the same way you did on your code. Spin complete, and make sure you have your single quotes. Even though you have this double dots and the /, those need to be inside the single quotes. Okay, so that will point to that spin complete. Let me make sure I actually spelled it that way, because I spelled it slightly different. Yeah, lowercase s, capital C. That's the standard camel caps way of coding. Spin complete .par .value 0. I think you've seen that before. So whenever you're dealing with constants, if you're going to read from a constant by specifying the channel that you want to look at. But you can't use that method for setting the value. You have to set the value by setting a parameter. So if you're going to be changing the value, you use par.value 0. If it's channel 2, it'd be value 1. If it's channel 3, it'd be value 2, right? Because it starts from 0. It starts from 0. So we're going to say par value 0 equals 0. And remember, we're just using a single equals because we're not doing any comparisons. We're actually setting this value, setting this variable. All right. So then on timer start, it will set that spin complete to 0 on spinner 1. Would I want to put this in spinner 2 and spinner 3 as well? No. No, because we just want the first thing that happens when the button value comes in to do that, right? And the spinner 2 is delayed and the spinner 3 is delayed. We don't need to do that 3 times. We will need to do the first thing first and the last thing last. So what would be the last thing? Would be when the spinner 3 ends or stops rolling. So that would be where we would change that spin complete to 1. So let's go inside spinner 3 and see what we can do. Anybody have a guess about which of the 3 scripting objects here we would want to put the change to spin complete to 1? Yeah, why?
Because it's the one that says when it rolls up.
Exactly, she's right. So like the first time I did this, I didn't think about that. And I put it on, I think I put it here under timer callbacks for complete on done. And I put it here. And it would work sometimes, but most of the time it wouldn't, because it would trigger that thing while the thing was still rolling slowly up. And so like it would say based on where it was at that point, but then it would roll right past it, and so it wouldn't make any sense. Like it was calculating it wrong. So yeah, you want to do it on that chop exec 3 that's telling us when the thing gets to the final value. So here, if, and it's going to be part of this if statement. So if op trigger 1 dot par sustain, if x equals less than 0.1, we're setting that sustain value back to 0 so the wheel stops spinning, and we're also going to set our spin complete to 1. Op single quote / spin complete single quote and parenthesis .par.value 0 equals 1.
So why is this equals and not equals?
Yeah, again, so like equals is a logic operator that is going to be comparing two values, but doesn't set a value. We're setting a value. So when you're setting a value, it's a single equals. When you're comparing two values, it's equals equals. All right, so now go ahead and hit the button, and you should, actually, let's do this. Here on spin complete, let's manually set this to 1, and then go ahead and hit the button, and when you hit the button, it should go to 0. And then the wheels will start rolling, and then the wheels will stop. And when they stop, it goes to 1. And when it goes to 1, the simple payout does its thing and says you lose. Let's go ahead and clear your text port so that you can see exactly what happens. And you should see a you lose, unless you're really lucky. 4, 3, oh, I might get it, 4, 3, 2. No, you lose. It worked. Is that working for everybody? Yeah? Okay. I'll give you guys a second. Make sure you get that going. Does anybody want to see something while I'm walking around? Oh, that's because you got to put spin complete inside of the parenthesis and then dot par dot value is 0. Spin complete, yeah. Get rid of that parenthesis. There you go. Anybody else have issue? What does yours say? Click on the red X. So let's see. Interrupt now. Where's the actual? Scroll down. Click on the red X again. Can you scroll on that? I don't even know what that's pointing to. All right, let's take a look at your code then. Maybe I can figure it out. Which one are you on? You're in the timer callbacks. Okay. So top exec 2 are now. Do you have the rest of the code in that? I feel like you're missing some code. I'll come back to you in a minute. Is yours working? Yeah. Great.
Yeah.
All right, let's take a look at what that should
Jump in
be.
there, and then
What are you in Spinner 1 right now? What container are you in? Spinner 1? Yeah? Okay. So let me. Yeah, so you're missing a lot of code there.
You got to do this in the other ones too. So jump out and go to the other one. So right click the chop exec. Yep. And then click edit contents and export. There you go. That's super handy.
And then do I have to save it or it just does it?
Nope, just does it.
I mean, you should save. Once you get something to work in your patch, you should save.
Save hard, save after.
Yep. And then, so do you have that in Spinner 1 done? Do you want to look at Spinner 3? So then in Spinner 3, you should have this. Well, do you have this code down here on done? On this is in Spinner 1, project 1, Spinner 1. Do you have this delay script stuff? So get that in here. This is all the stuff from the homework you should have had already. Okay, I'll have to come back to you because we probably won't have time for me to walk you through that code. It's all in the online video from last week. All right, so this works now we want to switch over to the, how are you doing, Gabe? Is yours working?
I need to catch up from last week.
Oh, okay. Okay. So next we need to do, we need to switch over to the fruit symbols and then start building our complex code, our complex win conditions, and we'll just see how much we get through those. If I have to, I'll just give you some of the code and let you finish it, finish what I was talking about. So let's see. First things first, switch over to fruit. So that's going to be in these wheel containers down here. The wheel geometry components down here. So go inside wheel 1, and right now we just have this text going to a flip, going to a fong, and that's getting mapped onto this material that is being applied to a tube. That's still going to stay the same. We're just going to add something other than this text 1 and plug that into the flip. So I gave you this, I believe, the first day that we started this annoying project, and so it's on the website under week 5, I believe. If you click on week 5, slotsymbols.png. So download that. And then once you've downloaded slotsymbols.png, then from your downloads or wherever you saved it, you can just drag that file into your patcher. Just put it right next to the text. Now, in order for this to be 7, count 1, 2, 3, 4, 5, 6, 7, but this counts from 0. So these are not, 7 is going to line up with like plum or orange or something instead of 7. So we'll have to make a slight adjustment to make that work. But go ahead and plug it in there into the flip.
So we're just taking out the text?
Yep. You can leave the text in there for now. I think it's helpful to have that in case you want to go back and analyze things.
No, for all 3?
Yeah, go ahead and do that for all 3. You could use a, what's it called, like a select top, but it's just easier and it doesn't use that much resources to just put 3 images in your patch. Like if you're doing 3 movies, that might be an issue, but these PNGs use no resources at all, hardly any resources at all, especially because they're kind of low res. All right, so now I have fruit. And the main thing I want to do is I'll know that everything's working if I put a 7 in this. If I make my null here be a 7, they should be a 7 centered on the wheel, or a little bit offset because we had to rotate it slightly because of the model is like slightly canted backwards. So I believe right now, if you click on this geometry component, the way this is working is we're saying op wheel post channel 0 times -36 degrees plus an offset of 52 degrees. We're probably going to have to change that offset to make 7 be 7. So let's go ahead and, in order to force this wheel to be 7, let's just go ahead and create a constant up here and plug that into the wheel post or this null coming out of your spinner 1. That way we can override what spinner is saying and just set it to be what we want. And now change this constant to have a value of 7. And now take a look at your thing, and mine's a plum. So it's a little bit off. You can see it's close. The next one up is a 7. So I need to adjust the offset to make the 7 be here in the middle. So right now, it's this plus 52 that is determining that. And so let me see, let's try plus 42. Nope, that's further away. So I need to go higher instead of lower. So 60. No. What it is, I'll just go ahead and give you what it is. At least for me, it's 90. 90 degrees puts that 7 right in the middle where I want it. So go ahead and change that offset on each one where it says plus 52. Change that to plus 90. Oh, what? Oh, haha. Just go ahead and do it. It won't put 7s on all of them because we only overrode that first wheel. But that's the only one we need to override to make sure we have it right. Once we know that that the offset is 90, we can just apply that offset to them. So I must have had a 7 in my third position right now. Yes, I do. Okay. Now that I've done that, I can get rid of my, let's get rid of that. Go away. Let me zoom in a little bit. I can get rid of this constant one. I don't need it anymore. I can re-hook up my spinner to that. And that will put the wheel back to where it needs to be. Let's go ahead and take a look at our beautiful slot machine with its lovely fruit. %. I'm gonna have to plug in my noisy power supply. Hopefully this won't be too bad. I'm sorry. You know what I can do is maybe I wrap it up in my jacket. It won't be so loud.
Do you want to just use mine?
You have enough battery? Can I borrow yours?
Yeah.
Okay, great. Yeah, that'd be awesome. Yeah, it's terrible. Maybe don't buy the cheap off-brand power adapters because they last less than a month. Oh, that's so much better. Okay, thank you. Okay, so yeah, cool. Now all we need to do is, well, one thing I need to do is I need to turn off the borders on this button. I don't want to have a big square like that. That's easy enough. That's here under the button. If your borders are turned on, you can turn them off too. Take it out of Viewer Active, click on it, and under Look, where it says border, left border, right border, bottom border, top border, and I had all those set to border A, just set those to off. Then it will be a completely invisible button. I only had those on so that I could tell where the heck the button was. Yeah, that's better. All right, cool. All right, so now we want to create a more complex payout scheme so that we win more often. And right now, ascending and descending makes no sense with fruit. Like, you're just confusing the heck out of everybody. So if you go online and you search for like slot machine payouts, you're going to find 1,000 different ones that are different for every machine, because it's kind of the point is that they definitely have things in common. All sevens is always usually a high payout. All bars is also usually a high payout. And all cherries sometimes is a high payout and sometimes it's a lower payout, but it's always all the same, always a flush, as they call it, all being all the same fruit is usually some level of payout, but which fruit, there's different tiers based on what fruit it is. So I went online and I tried to find a picture that seemed to have the same fruit that I have. And I found this, and it's a really old antique thing. It's on the website under week 7. I went ahead and clipped out a picture, and so I based my payouts on this. I didn't use the same numbers that they used. Week 7. So here's the picture I based this on. So any two cherries has a small payout of 3. 2 cherries and a bell is slightly higher. 2 cherries and a lemon is slightly higher than that. 2 oranges and a bar is the same as all 3 oranges. 2 plums and a bar is the same as all 3 plums. 2 bells in a bar is the same as all 3 bells. I don't know that I did all of those wildcard things because I just wanted to keep it a little bit simple. 3 bells is the next highest. 3 bars is kind of their jackpot. And then they also have this thing like bonus. I guess that has to do where it lands, may or may not add the next letter of the word. And then when you have all the letters, it pays out a jackpot. So I kind of based it on that, but I kind of made up my own thing. And I decided that jackpot was all 7s. And so I made this chart here for you guys. So jackpot is all 7s, and I decided that that pays out $500. And then the next highest is all 3 bars, and that pays out like $200. And these are the numbers. 7s are 7, bars are 0, bells are 9, and plums are 8, and it goes down from there. So bar, 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 bell, bell, bell is. So look at this as these. I'm calling these payout levels. So jackpot is kind of level 11. I just called it jackpot level. And then there's 10 payout levels below that. Bar, 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 bell, bell, bell. Bell, bell, bar is 8. 7 is plum, plum, plum. 6 is plum, plum, bar. 5 is orange, orange, orange. 4 is orange, orange, bar. 3 is any other flush that we haven't already talked about. 3 is cherry, cherry, lemon. 2 is cherry, cherry, bell, and 1 is any 2 cherries. So what would a cherry, cherry, cherry be? What level would that be? That'd be 3. And what would lemon, lemon, lemon be? Also 3. So and then what is orange, 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 for example, is 5, right? So some flushes are worth more than others. So basically, we need to define our jackpot the way we already have. Then we're doing an ELIF based on this, and then an ELIF based on this, and then an ELIF based on this. And this is where it gets a little bit weird because where does that bar land? Right now in the description, it's bell, bell, bar. But I think it's more fair that that bar could be in any of those positions as long as the other 2 are bell. So that means it's going to be 990 or 909 or 099. Just like same thing. Anytime that there's a wild card, 880 or 808 or 088. So we just need to, I'm going to get started. We have 12 minutes to write this complex code. Let's see what we can do. Okay. So here, let's go ahead and copy this simple payout and paste it. Let's go ahead and bypass the simple payout. Rename this complex payout. It doesn't really matter what you name these because we don't actually call on their names anywhere else in this patch yet. I don't think we will. But, okay. And then let's get rid of everything after jackpot because we're going to change everything else. So not everything in the code, but just all the code before return. Right? So strike all that. Okay? So this is jackpot. And we're gonna put a payout level, and we're gonna stick that in a constant. And so make a new constant, and call that constant award. Okay, so when you get an award, we'll put in the code to change the award from 0 to whatever you want. All right. So print jackpot, and we will add op, open parenthesis, single quote, award, close a single quote, close parenthesis, dot par dot value 0 equals 500. So you get $500 if you get a jackpot. Okay. If now we're going to add our elifs. Elif. Now, what are we testing for? We're testing for our level 10 payout, which is wheel 1 equals wheel 2 equals wheel 3 equals 0, right? Because 0 is bar. So elif wheel 1 equals wheel 2 equals wheel 3 equals 0. Okay. Let me grab. Actually, let's make a text dat. Make a text dat just for our own sanity here, and let's see if we can grab this from the website. I don't know that we can with a table. I hope we can. Grab all the text from the table and paste it into your text thing here. Whoa, no, that's not. Hold on, I gotta make my viewer active and then paste. There we go. Yeah, that's close enough. I think I can figure that out. All right, so this is what we did, bar, 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 which is, as you can see, 0, 0, 0 here, right? These don't quite line up, but I think you can figure it out. All right, so the next is bell, 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 which is gonna be a 999. So, oh, wait, sorry, we didn't finish this one. Sorry. Okay, so equals wheel 1 equals wheel 2 equals wheel 3 equals 0, colon, new line, print, single quote, level 10 payout, single quote, close parentheses. For now, oh, and op. Grab this op award, paste it in the next level, and change the 500 to, what's the payout? 100? No, 200. Okay, now we can just grab this elif and just duplicate it and change the conditions a little bit, and it won't be as much typing. So grab this elif, go to the new line, go back one tab, paste it in, and now we want, instead of 10, or instead of all these equaling 0, we want them all to equal 9. And then that payout is 100. And change this to from level 10 payout to level 9 payout. Go to the next line, get rid of the tab, paste in your elif. And now what's the next condition? Bell, bell, bar. All right, here's where it gets a little complicated. So we are saying all of these are equal to wheel 1 equals wheel 2. Let's see, what did I do before? Sorry. Wheel 1 equals wheel 1. Okay, I see what I did. Yeah, and there's all of these, you can write them more than one way. But I just kept this one simple. And so let's change this first, so that we don't get confused about what we're doing. Change this to level 8 payout and change the reward from 100 to 70. Not 270. All right, now we need to change this. And I'm just going to go ahead and specify exactly what each wheel should be. So wheel 1 equals 9. And then we have to say and wheel 2 equals 9. And wheel 3 equals 0. Is that right? Yeah. So that's the first way of doing it. That covers the 990. but it doesn't cover the 909 or the 099. So anybody have an idea of what I could do to add those extra conditions? Yeah, you could add more elifs below it for each of those, or you can add an or on the same line, which is probably less confusing in the long run. So we can add an or, and then the same thing here. Go ahead and just copy this sentence before that you constructed before the word or, paste that in, and now say wheel 1 equals 9, wheel 2 equals 0, and wheel 3 equals 9. And now one more or, and now paste it again. And wheel 3 equals 9, wheel 2 equals 9, but wheel 1 equals 0. I have an extra space in here. I don't think it matters, but I'm going to get rid of them anyway. So I'll do that one for you guys, but we won't do that for the rest of them because we don't have time. In fact, we only have 4 more minutes. But I think if I show you a few of these, you should be able to fill out the rest of them. And that's going to be your homework. Okay? Level 8 payout. Do I have any extra spaces? I have an extra space there. I don't think extra spaces matter. Okay, so level 8 payout. That's one's done. ELIF. What's 7? Seven is plum. Oh, great. This one's all the same. This one will be easy. 7 is just all plums. ELIF, wheel 1. Actually, here, I'm just going to paste. No, I'm going to grab the code from the jackpot, because that's the closest to what I'm going to be composing this time. Copy. And don't forget your colons at the end of these things, or it won't work. Did I put one in that long? Yes, I did. Good. All right, so ELIF, I'm going to paste the code from the lucky 7s and change it. Instead of 7s, this is plums, I believe, which is 8. Right? 888. Yeah, so just change this to 8. And that's going to be, I'll grab this print stuff and paste that in. But I have to tab it over. There we go. Print level 7 payout with an award of, what was level 7? Award of 50. Okay, let's see. ELIF. Oops, and I have a heel here instead of a wheel. There we go. What's the next one? All. Okay, plum bar. So this is going to be similar to the one before. This is going to be similar to level 8 payouts. So grab all of the code for level 8 payout, including the print and the award op, and paste that in there. And then change the values to conform to what the payout should be. So this, first of all, change this from level 8 payout to level 6 payout, and change the award from 70 to 40. And now it's, if they equal, what's it supposed to be? This is level 6 payout, so it should be 880 and every different thing of that. So here under 9, change that to an 8, 8, 0, or 8, 0, 8, or 0, 8. All right, and let's quit there. and I think you guys can figure out the rest of them. And so your homework will be, for those of you who didn't do last week's homework, you're going to have to go over that video and probably go over this week's video, which is why you need to do your homework, because otherwise it compounds and it gets harder and harder to catch up. And I don't want you guys dropping because you can't catch up, right? So do your homework and then finish this award structure all the way down to else you lose and pay out nothing, right? It's not as hard as it seems because we've already done pretty much all of the combinations. It's just changing those numbers to meet what's described here in this text and also on the website. Okay? Does that make sense? For now, let's just run this really quick. So complex payout, make sure this is attached to null 1. It is. Okay, and now when I activate it, does it break? If it does, then you probably have a typo somewhere. Mine didn't break, so I don't have a typo yet. Let's see if I happen to win one of the conditions we programmed. I doubt it. 1, 2, 1, 2, 1, 3, 6. That's definitely not going to win. All right, great. We'll see you next week. And if you get all caught up and you have problems still, please come make an appointment. Come see me. I can go over your code and try to fix whatever little issue you're having if you can't figure it out. Also, Shay is going to be having office hours, and he can help you out as well. But we don't want to just use our time up to do what you should have done in homework. So do your homework first and then make an appointment if you have problems. Okay? Great.